Okay, number 16, the average, that is the mean salary of the employees at a certain company is $43,000 with a standard deviation of $4,000. The average, that is the mean number of years of experience, is 4.8 with a standard deviation of 1.1 years. Compute the coefficients of variation and tell which is more variable, salary or experience. So remember, for the coefficients of variation, we have to take the standard deviation divided by the mean in that order and then times 100. So for salary, that would be $4,000 divided by $43,000 times 100, and that comes out to be about 9.3. So that's like a percent. When you multiply by 100, it's like you're converting from a decimal to a percentage. And then for years of experience, the coefficient of variation would be, again, standard deviation divided by mean. That would be 1.1 divided by 4.8 times 100. Comes out to be about 22.9. So which is more variable, salary or experience? The one with the higher coefficient of variation. Experience is more variable. There's more variation, more difference, more variability in how much experience these employees have than there is in how much money they make. And part B of this problem is another thing that if I put it on the test, it would be a bonus problem, because I told you didn't have to know this. But this is about Chebyshev's theorem. According to Chebyshev's theorem, at least 75% of the employees' salaries must be between... Well, Chebyshev's theorem said that for any set of numbers, at least 75% of all the numbers, all the data values, have to be within 2 standard deviations of the mean. That is, they have to be between the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation. Here the standard deviation is 4,000, so 2 standard deviations would be $8,000. So 43,000 minus 8,000 is 35,000, and 43,000 plus 8,000 is 51,000. So we're guaranteed that at least 75%, maybe more than that, maybe even all of them, but at least 75% of the employees' salaries must be somewhere between $35,000 and $51,000. Number 17, why is this frequency distribution incorrectly constructed? There are 2 things wrong with it, 2 reasons it's incorrectly constructed. One of them is the classes overlap. The upper limit of one class is sometimes the same number as the lower limit of the next class. So we don't know whether to count 5 here, or it shouldn't be counted twice. So that's one thing that's wrong. The other thing that's wrong is the classes are not all the same width. 1, 2, 3, 4, 5 has 5 numbers in it. 5, 6, 7, 8, 9 also has a width of 5, but 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 is a lot wider than that. And 20 to 25, 20, 21, 22, 23, 24, 25, that has a width of 6. So these are all over the place. They do not all have the same width. Finally, number 18. The Oregon State Legislature wants to estimate the length of time it takes a resident of Oregon to earn a bachelor's degree from a state college or university. A random sample was taken of 285 recent in-state graduates. It was determined that the graduates in the sample took an average or mean of 4.8 years to earn a bachelor's degree. First question about this little situation, what is the variable? What is the thing that varies from one individual to another that we're looking at different values of? Well, that would be the length of time it takes to earn a bachelor's degree. That's what they're dealing with here. Is that variable qualitative or quantitative? Quantitative would mean that it is a number, a quantity. And number of years, how long it takes, that is quantitative. What is the population? When you tell me what the population is, it never hurts to begin with the word all, because the population is all of the individuals that we care about. Every one of the type or category that we're considering here. Here, we want to estimate the length of time it takes a resident of Oregon to earn a bachelor's degree from a state college or university. So the population would be everybody who does that. All in-state graduates of Oregon state colleges or universities. What is the sample? Well, the sample is the 285 recent in-state graduates that they used to calculate that 4.8 years for the mean. They didn't want to have to look at every single person in the whole population, so they just took a sample. So those 285 people are the sample. And they're supposed to be representative of all in-state graduates of Oregon state colleges or universities, which would be the population. So if the mean is 4.8 years for the sample, you'd expect it to be somewhere close to that for the whole population. And later on in the semester, we'll get into relationships between samples and populations and how you can estimate the mean for the whole population based on what you see in your sample. So that's it for the review problems. Remember, there's also a sample test posted on Canvas that you can try working through and check your answers. If you have any questions, ask me. Hopefully this helped, and good luck on the test.